this video, I'm going to be going over concentrations and calculations. So there's two main equations that we want to be focusing on in this section, and that is the molarity equation here, and then that is also it's kind of like molarity ratio equation. I don't know if there's like any specific name for it, but that one is the molarity of the concentrate times the volume of the concentrate is equal to the molarity of the dilute times the volume of the dilute. And molarity is in moles per liter, which is the molarity equation. And then volume is usually in liters. But yeah, so I usually try to keep it in liters, and then if the question asks for something in milliliters, then I give it in milliliters, etc. Okay, so I have some practice problems. Let me just make sure that I have the right one. Yeah, so we'll start with this one, right? So we have 15 liters of a 20 molarity solution. How much 0.1 molar dilute can you make? So the equation that we're going to use for this is MCVC is equal to MDVD. So the molarity of the concentrate is 20 molar. So we have 20 molar. And then the volume is 15 liters. So we're going to write 15 liters in there. And then how much 0.1 dilute, 0.1 molar dilute. So we're going to do 0.1 molar times VD. So we want to find out how much. So we're looking for the volume, right? Volume is a measurement of an amount, basically. So that's how we're going to find out how much we can make. So we're just going to do some basic algebra here. We're going to do 20 times 15 to our calculator, and we're going to get 300. So 300, and then this would be like moles per liter, which is technically moles, but yeah, moles times liter is equal to 0.1 mole VD. And again, just going to do some basic algebra here and divide each by 0.1 mole, so we can cancel those, and we can cancel the moles there so that we know we can get liters, and then that means that VD will be 300 divided by 0.1. So the amount of dilute that we can make is 3,000 liters, and that would be your answer. It's pretty fascinating when you have something that's 20 molar and you only have 15 liters of it, and you want to make a dilute that's 0.1 molar, you can make a you know how much ton of it, right? So that's pretty fascinating one to do. Okay, so now here's one that deals with molarity. So we have 235 grams of C12H22O11, and you place it in 5 liters of DI water. Assuming that it's going to be aqueous, what is the molarity of the new solution, right? So we know that the molarity equation is moles divided by liters, right? So we have the liters, but where do we get moles from? As Professor Sherlock always says, converting grams to moles is like breathing in chemistry, so it's something you have to do a lot. So what we're going to have to do is we're going to have to convert these grams into moles, right? So how we do that is we do 235 grams over 1. We're just doing dimensional analysis here, and let me write this out exactly what this is that we're dealing with, just so that we know, times the molar weight of it, right? So the molar weight, we can calculate that. So we have 12 carbons, which are 12.11 grams. We're going to add that to 22 hydrogens, which are I think it's 1.008 grams, and then again, this is all from the periodic table. You do not have to memorize any of this stuff. I just know it off the top of my head from doing these calculations so many times. Oxygen, we have 11 of those, and they are 15.99 grams. Okay, so the molar mass of this is 342.297. You may get some different numbers just based on how you round, but the overall final number that we get should be pretty much the same. So what we're going to do is we're going to do 235.0, and we're going to multiply that by 1 divided by 3 42.297, and we are going to get 0.687 moles, right? So that's how many moles of that compound that we had. In your calculator, you might get a number that's closer to 0.68653, but because we were given it in 3 sig figs, we have to give the answer in 3 sig figs. Also, same here. When we do the rest of the calculations, we only have to do 1 sig fig because it's only given 1 sig fig, right? So now what we do is we do the molarity is equal to 0.687 moles of that C12H22O11, and then we have 5 liters of the water. So then the molarity is going to be equal to, we do that number divided by 5, and we should get something like 0.137, but again, we're going to round to 1 sig fig, which will give us 1.1 molarity. Right. So that is our answer there. Again, the answer was actually 0.137 about, but with the sig figs we rounded it to 0.1. Okay, so the last question is a practice question. I'm also going to throw in a little bit of like a challenge in there. Much H2O needed. Okay, so the question reads, you need a 2 mole, 0.5 liter solution of NaCl, but you only have 4 molarity solution of NaCl. How much of the 4 molarity solution will you need in order to make the needed solution? And then the tough question is how much H2O is needed to add to that in order to get that amount that you need. So you guys can pause and practice this question on your own. I'm going to be going over it in 3, 2, 1. Okay, so so we have this, and that. We want this in milliliters. I'm just gonna like underline that just so that we know at the end we want it in milliliters. So we're gonna use the same equation that we have been using. MC/VC is equal to MD/VD. So the concentrate, we need that, so that's not the concentrate. So we have this 4 mole solution, 4 molarity. So we're gonna write 4 molarity, VC is equal to MdVd. How much? Okay, so MD is going to be 2 moles. VD is going to be 0.5 liters. So we're going to do the same thing. We're doing the basic algebra. I'm not going to do out the whole thing. But I get that VC is equal to 0.25 liters. Again, we want this to be in milliliters, right? So what we're going to do is we are going to do 0.25 liters divided by 1 times the, what you have to do in order to get it in milliliters. So milliliters, I know there's 1,000 milliliters in a liter, so I'm going to do this. So we're going to cancel out liters, and we should, right? Let me ask Alexa. Let me just check to make sure. Alexa, how many milliliters in a liter? Alexa? Oh man, is my Alexa not working? Oh, I have... My pajamas were covering it. Guys, this is getting a little too personal. I'm so sorry. Alexa, how many milliliters in a liter? 1,000. Let's go. Memoration game on point, you know? Okay, times 1,000. So we get 250 milliliters needed. Now, the challenge question is how much H2O is needed in order to do this, right? So let's think of this question like this, right? So we have a beaker. Oh my god, that is a horribly drawn beaker. right? So let's say that this is the 0.5 liter mark, right? So what we have right now is 250 milliliters of this solution. That's how much we need. So in order to fill the rest of this and get the 0.5 liters that we need, how much water is needed, right? So what do we need in order to get it to 0.5 liters, if that makes sense? Okay, so we want to get to 0.5 liters. So I'm going to do this in milliliters as well. So we have 0.5 liters divided by 1 times, we're going to do the same thing, 1,000 milliliters over 1 liter. Oh my god, that was horribly drawn, but you know what I mean. So we need to get it to 500 milliliters. So our goal is 500 milliliters. So that's going to be equal to what we have, milliliters, plus what we need in milliliters. So all we have to do is do 500. Again, we're just doing some basic algebra stuff here. 500 minus 250, and we get that there is 250 milliliters of H2O needed for this solution. So you end up doing kind of like half and half, and you'll get the answer that you need. So cool. So that's all of the practice and all of the questions that I had for that. Same thing as always, if you have questions, feel free to reach out, and thank you.